Night after night, the moon keeps watch. It rises in silence, luminous and solemn, tracing the same steady arc it has for billions of years. Long before the first human wrote a word, before we tamed fire, before life ever crawled from the sea, the moon was there, an unblinking witness to the unfolding of Earth's story. We have written poems to it, sailed by its tides, measured months in its phases, and yet for all its constancy, for all the time it has hovered in our skies, we've only recently begun to uncover its astonishing origin. The moon did not form peacefully beside Earth. It was not gently adopted from elsewhere. The moon was born in fire, in the most catastrophic event in our planet's history. Its existence is not an accident. It is the product of destruction, a child of planetary violence that left both the Earth and the moon forever changed. To know how the moon came to be is to journey back, far beyond recorded time, beyond the oldest fossils, beyond even the formation of oceans. We must go to the very edge of planetary formation, to the chaos, to the impact, to the moment when two worlds became one and a third was born from their collision. In the early solar system, order was still a rumor. Gravity had begun its patient work, clumping dust into rocks, rocks into planetesimals, planetesimals into protoplanets. But the process was brutal. Nothing formed without conflict. Everything that grew did so by smashing into something else. Earth was no exception. In its infancy, it was a molten world, half-formed, with no continents, no oceans, no atmosphere as we know it. The surface churned with magma seas. The crust had barely cooled before being shattered again by incoming debris. The moon didn't yet exist. Neither did stability. This period, known to scientists as the Hadean Aeon, was named after the Greek underworld, and for good reason. It was a hellish time. Asteroids pelted the surface daily. Temperatures fluctuated wildly. The planet's surface boiled, froze, and boiled again. Yet beneath the chaos, the seeds of a stable Earth were germinating. And into this seething cauldron came an intruder, Theia. We may never find physical evidence of Theia. It left no intact fossils, no clear remains. And yet, we know it existed, not through its presence, but through its absence. The moon's very being is a shadow of Theia's violent fate. Theia is believed to have been a Mars-sized body, roughly 1/10 the mass of Earth. It may have formed in a nearby orbit, caught in a gravitational tug-of-war with our young planet. For millions of years, the two worlds circled the sun like wary dancers, their paths drawing ever closer. Until, one day, they collided. This wasn't a gentle nudge. It was a glancing, high-velocity impact that changed everything. The energy unleashed in the collision exceeded anything Earth has experienced since. The crusts of both planets were vaporized. Oceans of magma splashed into orbit. A planetary wound was opened, and from that wound, the moon would rise. The Theia impact is one of the most violent events in the history of the solar system. When it struck, the kinetic energy converted into heat instantaneously. The atmosphere was incinerated. Much of Earth's outer mantle was torn away and cast into space. Theia, too, was obliterated, its metal core merging with Earth's, its outer layers thrown outward in a fiery spiral. From the molten chaos, a disk of debris formed around the Earth. It was vast, stretching thousands of kilometers, and impossibly hot, glowing with infrared light, its particles colliding, merging, vaporizing, cooling. This was not a ring like Saturn's. It was a disk of creation, and inside this disk, gravity was already at work. Particles began clumping together. Dust gathered into boulders. Boulders became moonlets. Moonlets collided and coalesced. In a matter of months or years, an eye blink in geological time, a single body emerged. Our moon. The newborn moon was nothing like the serene orb we see today. It glowed with its own heat, its surface a sea of lava. Orbiting Earth at only a fraction of its current distance, it filled the night sky like a god, massive, red, and roiling. It exerted a powerful gravitational pull, raising tides hundreds of meters high in Earth's molten seas. The heat from the impact kept both bodies in a state of semi-molten turmoil. Over time, the moon began to cool, forming a crust while still being battered by leftover debris from the solar system's construction. These collisions left their mark, creating basins that would one day become the Maria, the dark plains visible from Earth. Meanwhile, the Earth's own rotation began to slow, dragged by the moon's tidal forces. The first whispers of our current day-night rhythm had begun. The Earth-Moon system, forged in violence, was now dancing in gravity's embrace. The story of the moon's formation isn't just written in theory. It's written in rock, in isotopes, and in the quiet clues locked within lunar soil. When the Apollo astronauts brought back samples from the moon, scientists noticed something strange. The moon's rocks were nearly identical in isotopic composition to Earth's, particularly in oxygen. This meant that the moon was not foreign. It wasn't a captured object. It was us. And yet, the moon had clear differences. It lacked volatile elements, compounds that evaporate at high temperatures, indicating it had formed in extreme heat. Its iron content was far lower than Earth's, supporting the idea that the moon came from the crust and mantle, not the core, of Earth and Theia. Every lunar rock is a piece of the puzzle. Every crater a fossilized echo of a violent past. The moon is not just a companion, it is a record. It carries the fingerprints of its fiery birth. Without the moon, Earth might be unrecognizable. The moon stabilizes Earth's axial tilt. This stability prevents wild swings in climate, swings that could make it impossible for complex life to evolve. The tides it raises stir the oceans, distributing heat and nutrients, creating the conditions for biology to flourish. It even helps moderate the speed of Earth's spin, slowing our once rapid rotation to the 24-hour rhythm we know today. Some scientists believe the early moon may have been essential for kickstarting life itself. Tidal pools, stirred by lunar gravity, may have concentrated organic molecules. Evaporation cycles driven by tides could have sparked the chemistry of life. The moon, born of destruction, became a force for balance, a regulator, a partner. Without it, Earth might still be a lifeless rock orbiting the sun. Before the giant impact theory took center stage, other ideas held sway. The co-formation theory suggested that the moon formed alongside Earth from the same cloud of material. But this couldn't explain the moon's smaller iron core or the extreme similarity in isotopes. The capture theory proposed that the moon formed elsewhere and was pulled in by Earth's gravity. But orbital mechanics make this scenario highly unlikely, and it doesn't match the chemical evidence. The fission theory, once widely accepted, claimed that the moon spun off from a rapidly rotating Earth. But modern physics shows Earth could never have spun fast enough for this to occur. Only the giant impact theory explains everything: the mass, the motion, the chemistry, the heat. It ties the story together. Not perfectly, science is always evolving, but more completely than any other model. The moon is our celestial twin, torn from us in fire, yet bound to us ever since. It is a survivor, a beacon, a reminder that from violence can come beauty, from destruction can come harmony. It watches over us still, turning slowly in perfect rhythm with our own spin. One face always turned toward us, as if it remembers what we once were. A single world, broken and reborn. We have walked its surface, left footprints in its dust, and stared at Earth from its horizon. In doing so, we've glimpsed our past and our future. The moon is not just a satellite. It is the memory of our beginning.